Hello everyone. In this video, we are going to discuss about Karnaugh Maps. So here in board examination, you will get at least 20 marks out of 70 based on the Karnaugh Map, that is K Maps. So in this video, we are going to see the introduction of K Maps. So first we will see some key points. Karnaugh Map or K Map is a graphical display of the fundamental products in a truth table. That is, it is a different way of preparing a truth table. You already discussed about truth table, how to create truth table and how to get the results. Okay, based on input, how to get the output. Same way in K Map, you are going to display the truth table in graphical way. Okay, so we'll be discussing it one by one. Karnaugh map is nothing but a rectangle made up of certain number of squares, each square representing a max term or min term. That means it is an output that squares will have the output column, right? So because the output will be based on the input, okay, you will be either get the based on that output you will be getting either max term or a min term. So basically K map is a rectangle which has some square boxes. So we will be discussing what are that. Okay. In SOP reduction, each square of K map represents a min term. Okay. So that means in POS it represents max terms. Okay. That's what it means. Thus for a function of n variables, there would be a map of 2n squares 2 to the power n. Okay, each representing a min term. So for example, if you have a 2 variable function, it will be 2 to the power 2, that is 4 square boxes. If it is a 3 variable function, then you will have 2 to the power 3, you will have totally 8 boxes. Same way, if you have 4 variables, then it will be 2 to the power 4, that is 16 boxes. So it goes on like that. Okay, each representing a min term. So every box represents min term. Fill the squares with ones whose min terms leads to output 1. So in truth table, there will be some column, some rows with ones and some rows with zeros. Okay. So same way in K map also, you are going to fill ones where the output is 1 and where the output is 0, you are going to fill it with 0 based on the min terms. Now, you are going to see the first K map. Okay. So we will briefly explain you what is this and then we will go to the remaining K maps representation. So it is a 2 variable K map representing min terms. Okay, first you have to basically understand what is this K map and how to design this. So since it is a 2 variable, you can see namely x and y are the 2 variables. Okay, I'll show you that. Right. So this is x and this is y. That is the left side part is x and then the top part is y. Okay, it's same like your Excel sheet where you have rows and column labels. You are going to combine both and make it as a cell address. Same way here, you got first box, that is x dash. Okay, that is first row, and then you got x. Okay, that are the 2 combinations available for x, that is 0 and 1. Same way y also have 2 combinations, 0 and 1. So 0 represents y dash and 1 represents y. Okay, so when you combine this, you will get x dash y dash. Okay, that is the first box. Okay, same way second box, square box is x dash and then y. So when you read it, you have to, that is when you that is the meeting point and you have to give the address for that. Okay, same like in Excel where you will give the cell address, combining both the rows and column labels. Here also you are going to do that. Okay, here you can see the second row x and the first column is y dash. So when you combine that, you will get x y dash. Okay, and then the final one is x and y. Okay, that is the final box. Okay, since it is a 2 variable, as we discussed previously, previous slide, it is 2 to the power n. Okay, 2 to the power 2 is 4 boxes. So you can see 4 boxes here. How to name these 4 boxes is you have to start with 0. First box will be always 0. Then second box is 1. So you have to label it from left to right. After completing the first row, then you have to start the next row, that is 2 and 3. So 0, 1, 2, 3. So this is how you are going to represent 2 variable K maps representing min terms. Now you are going to see 3 variable K maps representing min terms. So since it is 3 variables, you can see left hand side you got x, and right on top you can see y, z. Two variables been represented on top, and then only one variable in the left hand side. Okay, the same way you got 0 and 1 are the two combinations available for single variable x dash and x. But for y in z, since it is two variable, you will have four combinations: 0 0 0 0 1, 1 1 and 1 0. So we'll come to this later. So 0 0 will be nothing but y dash z dash, 0 1 is y dash z, 1 1 is y dash z, y and z, and 1 0 is y z dash. Okay, so when you combine this, you will get x dash y dash z. So you will get this. Okay, and x dash, the whole row will be x dash, and then you have to write. So x dash y dash z, x dash y z, and x dash y z dash. Okay. And here you can see the second row which has x. So all the boxes in the second row will be starting with x, and then you have to represent the columns x y dash z dash, x y dash z, x y z, and x y z dash. So based on the columns you are going to name it. So this is how you are going to represent the three variable minterms. Now basically how it look like is it has 8 boxes because it is 3 variables. So 2 to the power 3 is 8. So you'll have 8 boxes. You have to number it from left to right. But when you notice one thing, whenever you write the truth table, it will be starting from 0, 1, 2 and 3, right? Because you can see here 0, 0 is a representation of the binary value. It is a representation of decimal value 0. It is a binary representation. 0, 1, the decimal value is 1. Okay, and here 1, 1 is a representation of the decimal value 3. And then you have the representation, that is 1 0, it is for 2. That means 0, 1, 3 and 2. Okay. So here also whenever you number it, you have to write as it is. So 0, 1, then you have to go to the last box, that is 2, and then you have to come back to the previous box, that is 3. Okay, we will tell you why it is. Okay, and here you can see second row. After numbering the first row, you have to go to the second row. This is 4, 5, 6 and 7, right? So you have to, when you look at it, it will be 4, 5, 7 and 6. But when you write it, you have to write 4, 5, second box, and go to the last box, that is 6, and then come back to the previous box and then write 7. So when you number it, it will be easy for you to fill the min terms or max terms. Okay. Next is 4 variable K-map representing min terms. Since it is 4 variables, I am introducing an extra variable, that is W, X, Y, Z. So Wx will be represented in the left hand side rows, and then columns will be represented with yz. So since it is 2 variables, you will have 4 combinations. It is basically like dividing the truth table into 2 halves, right? So normally you will have 8 rows in truth table representing 4 variables. Actually 16 rows. It has been combined and made it into a 4 row and 4 column, right? Now you can see the same thing here, 0 0 0 1 1 1 and 1 0. We already discussed about it. So you have to write the representation w dash is x dash, w dash x, wx and wx dash. Okay, this is left hand side. Same way here also you have to write 0 0 0 1 1 1 and 1 0. Okay, y dash z dash, y dash z, yz and yz dash. So after filling this, just combine both. Once you fill this, you know what it is. You just fill it up. So this row will be having fully w dash and x dash. The remaining you have to write the columns. So w dash x dash, y dash z dash, same like that. W dash x dash, y dash z. So it goes on like that. Second row you have w dash and x. So here all the values starts with w dash x, and remaining things you have to fill it with the based on the column values, right? So you will have the complete 16 boxes here. Now when you number it, so you can see the right hand side box. This is how your actual K-map, 4 variable K-map look like. You won't have all the values. You will have only the blank boxes like this. You are going to fill the numbers, min terms by representing 1 or zeros. Okay. So when you number it, you have to start from the first row. So you will have to put 0, 1. Then you have to see the next row, it is 3 and then 2. So when you number it, you put 0, 1, go to the last box, and that is the first row, last box, and put 2 and then come back to 3. And here you got 4, 5, and 6 and 7, right? So go to the last box 6 and then put 7. Now same way, when you, it is not only for the right hand side part, it is also for the bottom row. Okay, you have to go after 7, you have to go to the last box, okay, that is last row, and start with 8, 9, go to the last box and write 10 and then come back to 11. So here you, when you see from top to bottom, you have to do this, okay. Then you have to start with 12, 13 and then go to the last box 14 and write the previous box 15. So basically you may be wondering why we are doing this, okay. Normally you will have binary code, but K maps represents the gray code. This is what you're going to discuss next. Okay, anyway, I'll explain you by showing you the table itself. Normally, K map, it is not a flat chart type box, or you can say rectangle. It is like a cylinder or like a globe. That means all the edges will be joining together. Okay, that means the left box and right box can be joined. Same way, top row and the bottom row can be joined. So when you look like it, look like cylinder, or it look like a globe or a ball like structure, spear like structure. Okay, so that's the reason you are doing this. Okay, one more basic thing is each and every from first row to the second row, when you notice, you can see 0 0. You can see the next one, it is 0 1. That means one variable changes its state. Here you can see w dash x dash. Second row it is w dash, it is same, but x value has changed state to x dash to x. Okay. Same way, when you move on to the next one, you can see 1 1. That means w dash has changed its state to w, but x dash is, remains the same. So here next row you can see w dash is same and x dash changes its what do you say, the value, that is a position, or you can say state. Okay, now when you rotate the when you join the top of and the bottom of, it will continue, it will be continuing. So you can see w and x dash here. Okay, when you join the first row, it becomes w dash and x dash. That means x dash remains the same and w changes its state. So this is the reason why we are using this type of gray code instead of binary code. Okay, you call it as gray code. Only one variable changes its state every time. Whenever you move on to the first row to second row, or first column to second column, it will change, only one variable will change its state. So you can notice here also y dash z dash, you can see y dash z. So z is changing the state, but y dash does not change the state. So here's the next one, you can see y z. Here z does not change the state, but y dash from y dash to y, it changes the state. Same way here also you can see yz is changed to yz dash. So z is changed its state to z dash, but y remains the same. So when you join the right hand side part and the left hand side part, that is both the columns, again you will see that there will be only one variable which changes its state, y and z dash. Here you can see y dash and z dash. So here y has changed its state to y dash. Okay, z dash remains the same. Why we are doing it? This is whenever you use a Boolean expression, when you want to minimize that using K map, when you use this type of gray code, it is easy and it will minimize, it reduce the expression to its most. Okay. Now you are going to see what is this actually. Observe the binary numbers from top to top of the K map, and these do not follow the binary progression. Instead of they differ by only one place. When moving from left to right, that is 0 0 0 1 1 1 and 1 0. Just now I want to show you the K map and explain you. Okay, it has been given as a notes here. You can go through that. It is done so that only one variable changes from complemented to uncomplemented form, and all vice versa also it will be done. This binary code 0 0 0 1 1 1 1 0 is called as gray code here. Gray code is a binary code which each successive number differs only in one place. That means only one variable changes its state. Okay. So hope you understood this video. We'll meet you in the next video. Till then, thank you.